Okay, so in this video, we're going to take a look at how we can use exponent rules to solve some more complicated looking expressions involving exponents. So let's take a look at the first question. First, we're going to deal with the numerator and denominator separately. So first things first, I wanted to simplify the numerator. So we have 2a squared. I'm just going to leave that first bit. And I'm going to deal with this bracket first by multiplying the exponents. So a to the power of 5 to the power of 3 would give me a to the power of 15 because I'm just multiplying 3 by 5 to get 15. And then in the denominator, I'm still going to have a to the 8b. I can't really do anything with the denominator here. I can't simplify it because the variables are different, so I can't add the exponents or anything. Now in the numerator, I can still do a little bit more. So a squared times a to the 15, we know we can write that as a to the power of 17. So you just add those exponents because we're multiplying. And we are left with the same denominator. And now we can simplify the numerator with the denominator. So 2 and 8, we can simplify that. Think of that as a fraction. So if you wanted to simplify that, we're going to divide the top and bottom by 2. So in the numerator, we'd have a 1, and in the denominator, we'd have a 4. So we know we have a 4 in the denominator and a 1 in the numerator, which I'm not going to write. Then we have a to the power of 7 divided by a to the power of 8. So even though it looks like it's a fraction, we could always think of a fraction as division. So a to the power of 17 divided by a to the power of 8. And remember, the rule is to subtract, so 17 minus 8. And that would give us a to the power of 9. So I'm going to leave that there. And then for the b, I can't do anything, so I'm just going to leave that in the denominator. So that's the first example done. Let's move on to the next one. So here's the next problem. So you can take a look. What I would recommend when you see square roots, symbols, and fractional exponents is to write everything in terms of exponents. So 4 to the 2/3, we're going to leave that as is. But the cube root of 4, we're going to rewrite that as 4 to the power of 1/3. Okay. And in the denominator, we're going to have 4 to the power of 5 divided by 3. So that 3 became the denominator in the exponent. Now we're going to use exponent rules. So in the numerator, we're multiplying, so we can add the exponents. So 2/3 plus 1/3 is 3/3, or just 1. Divided by 4 to the power of 5/3. And then the rule here is 4 to the power of 1 subtract, so the rule is to subtract 5 over 3. So think of this as 3 over 3 subtract 5 over 3. That would give you negative 2 over 3, which if you want, you can write that in the denominator with a positive exponent. Okay, so that's that example. Let's move on to the next one. So this next example, it may look complicated, but it's not too bad. We just need to deal with it one step at a time. So the first thing we're going to do is we're going to replace the roots with fraction exponents. So the 5th root, we're going to replace that with the exponent of 1/5. And the 4th root, we're going to replace that with a power of 1/4. Now we're going to work with the numerator and denominator separately. So for the numerator, we have, remember when we have negative 243 to the power of 1/5 times x to the negative 15 to the power of 1/5 all over 81 to the power of 1/4 times x to the power of 16 to the power of 1/4. So what I did was I basically raised every term. So what I did here was I raised every coefficient and every variable to the 1/5 in both the numerator and the denominator. Now, the next thing I need to do is take negative 243 and raise it to the power of 1/5. So that's the 5th root of negative 243, which ends up being negative 3. You can check that with a calculator. X to the power of negative 15 to the power of 1/5, you just multiply, and that gets you x to the power of negative 3. In the denominator, we have 81 to the quarter, which is 3, because that's the 4th root of 81, which is 3. And then x to the 16 to the power of a quarter, you multiply the 16 and the quarter. That gets you x to the power of 4. Now we just need to simplify. So the 3's will cancel. And so we're left with negative x and then minus 3 minus 4, which gives us negative 7. So I'm just subtracting the exponents at the end. And that gets us our final answer, which you can write as negative 1 over x to the positive 7. So in this example, we have lots of powers to do. So we're going to work our way from the inside out. So I'm going to deal with this 0.2 at the very end. But first, do note that 0.2 is 1 over 5. So we'll use that later. So that's going to be 1 over 5. I'm going to use square brackets, put that on the outside. Inside the square brackets, what I'm going to do is first deal with the numerator and denominator separately. So for the numerator, I'm just going to raise everything to the power of negative 2. So I have 32 to the negative 2 times x to the negative 10. So negative 2 times 5. And in the denominator, I'm also going to have x to the negative 10. And now notice the x to the negative 10's cancel, so that makes things a lot nicer. So we have 32 to the power of negative 2 to the power of 1/5. Now before I raise 32 to the power of negative 2, what I'm going to do is multiply the exponent, so that gets me 32 to the power of negative 2 over 5, which is the same as 1 over 32 to the positive 2 over 5. And now I'm going to take the fifth root before I square. So I'm going to write this as the fifth root of 32 to the power of 2. And the fifth root of 32 is a nice number. It's just 2, and then 2 squared is 4. So the final answer is a quarter. And this is the last example. So again, we're going to deal with it the same way. So first we're going to take the square root and think of it as power of a half. And inside, we're going to work with the numerator and denominator separately first, and then we're going to combine. So 18 times 32 is 576. M to the negative 5 times n squared gives us m to the negative 3. N squared times n would give us n cubed, so that's 2 plus 1. And in the denominator, we have 4m n to the negative 3. Next, we're going to simplify, so 576 divided by 4, which would give us 144 in the numerator and 1 in the denominator. M to the negative 3 subtract 1 would give us m to the negative 4. N to the 3 subtract negative 3 would give us n to the 6, all raised to the power of 1/2. Now I'm just going to raise every single thing we have here to the power of 1/2, so 144 to the 1/2. M to the negative 4 to the 1/2, and n to the 6 to the 1/2. So a half, think of it as square root. So 144, the square root of 144 is 12. And then over here, we're just going to multiply the half. So negative 4 times a half, well, that's negative 2. 6 times a half, that's 3. And then we're going to take the negative exponent and put it in the denominator with a positive exponent. So 12n cubed, so I'm going to keep the n cubed in the numerator, but the m, I'm going to put it in the denominator as m squared, and that's going to be our final answer.